All right, hello and welcome everyone to Ether Roundtable 106. Tonight we're going to be doing a little Shankland review. In a previous episode on a reading night, we read from the Robert paper, and we'll do a brief overview of that towards the end. But yeah, I wanted to go over this because it's been a conversation that's come up recently. And in a recent presentation I did, I was going over the Michelson-Morley data, and I never really paid attention before or noticed this, but even in their own first measurement that they show here, they show that the speed of light is different in the east direction versus the west direction. So it'll be interesting. And then these correspond. Once you make enough measurements, you can extrapolate a sidereal and annual solar periodicity out of these, where the speed of light reaches minimum and maximum dimensions on specific days. So that's pretty interesting. So we're going to look at the explanations that have been put forward to try and wrap this up, to say that these measurements are some sort of error, that they don't exist, because obviously in a speed of light that's variant in either direction would falsify relativity theory. They can't have an anisotropic speed. Their whole theory is dependent on an isotropic speed. So we're going to read one of the biggest mainstream textbook cited authors of a paper who is supposed to have refuted Dayton Miller's work. His name is Robert Shankland. He was a former lab assistant and student of Miller's. So they worked very closely. He knows the data very intimately. So we'll see what what his review is, what his take on it is. And I'll go ahead and lead us in here. So, a new analysis of the interferometer observations of Dayton C. Miller by Robert Shankland and his boys. For nearly 13 years, the results of the Michelson-Morley experiment obtained by Dayton Miller on Mount Wilson have stood at variance with all the other trials of this experiment. So what he'll go on to talk about is Kennedy Thorndike primarily, and a couple of other ones. But even in those ones, Kennedy and Thorndike, they used an asymmetrical configuration instead of the symmetrical one, and that gave a velocity of 26 kilometers a second, which is very close to their much desired 30 kilometers, and they throw that out as a null, because they can't have the asymmetrical one produce that, and then like the regular one that obviously should be producing the same thing not work. So like they even when they got close with their asymmetrical apparatus, they round that down to a straight zero. Imagine getting almost like, let me show you their theoretical predicted value here for 30, right? They measured just over 1 with a regular interferometer, but with the Kennedy and Thorndike, they came super close to up here, and then they still threw it out because they were already committed to not acknowledging the anisotropic nature of the speed of light and ether and all that, because the direct implication is that the Earth should have a relative velocity to it, and that's never once been measured outside of aberration in air. So anyway, we'll go ahead and continue here. As interest in Miller's results have continued to the present time, and since the original data sheets are available to the present writers, it seemed appropriate that these observations be subject to a new analysis. It is now shown that the small periodic fringe displacement found by Miller are due part to the statistical fluctuations in the readings of the fringe positions in a very difficult experiment. The remaining systemic error effects are ascribed to local temperature conditions. These were much more troublesome at Mount Wilson, and those were encountered by the experiments elsewhere, including by Miller himself and his work at the Case in Cleveland. So, yeah, at Case and in Cleveland. So, the what he did in Cleveland was where his controlled apparatus was, and it was in a basement. So they're saying that different times a year, different times of night, complete different location. California and Ohio are, on opposite coast of America. You're saying the same temperature fluctuation just persist all the way in a basement in a controlled lab environment, and also in a free range tiki hut that he built that's made out of hay or whatever. So, so that's cool. And then also, yeah. Anyway, So as it has been interpreted in the present study from Miller's extensive Mount Wilson data contained no effect of the kind predicted by the ether theory and within the limitations imposed by the local disturbances which consisted by the null result of the epochs of the year. And actually, I'm so sorry. I totally forgot. Before we begin, Angling Alchemy has a presentation to do. Has a quick 10-page presentation. I'm so
Got
sorry.
super into it. You
I I'm
super
so
hardcore leap
I'm so
into it. It's
sorry.
okay. It's all right.
Oh man, I had the wrong thing up and I was committed to the Nicholson Morley thing. My bad. Are you there, Colin?
You're hilarious, bro. All
Dude,
good, dude.
hard break on the routing. Sorry guys. I'm so sorry. All right, Colin, whenever you're ready, good sir. I got the Prezi up.
All good. Yeah. Yeah. Shout out to all the homies in the YouTube chat. Let's get it rolling. It's just going to be a quick hitter anyway.
Awesome. All right, so the community showcase Prezi, the significance of the lab frame by Angling Alchemy. Go ahead whenever you're ready, sir. Just tell me when to change slides.
Oh, nice. Okay, cool.
And shout
All
out
right,
to
cool. Yeah, you
Cass.
can go
Cass
first.
is here.
Yeah.
The original lab frame. Oh, dude, did this man make transitions, bro?
That's funny. So the fringe shift, C plus or minus V. We've all heard before, and I'm obviously going somewhere specific with this. So.
Oh, hold
Light
on.
has a preferred direction, proving a dynamic. What?
Hold on, you were kind of lagging a second.
Oh,
You're
okay.
roboting a fair bit, yeah.
As soon as you started, he said a robot,
All right.
but you seem to be all right now.
Yeah, you seem good now.
Yeah, just start again. Go for it, man.
All right, cool. Yeah. The fringe shift, C plus or minus V. Everybody in here has seen this before with the laser interferometry. So light has a preferred direction, proving a dynamic ether, but in relation to what? Next slide, yo. And everything from Newton's bucket to laser interferometry, the lab frame is the constant. So if you're not familiar with Newton's bucket here, simply if you're standing still on the ground and you watch the bucket spin, you will predict that there will be a vortex. But if you attach yourself to the bucket frame, if you will, on the bucket, you wouldn't predict any motion, but there would be a vortex. You'd make the wrong prediction. Super simple.
England,
Yeah.
excuse me, brother. I'm sorry. This is Shalom. Alan, we're not getting the Prezi on YouTube, by the way.
What?
The slides aren't showing up. Yeah. You got complainers in the old chat room.
Oh.
Yeah.
Oh, so they
Nobody
didn't
these
see
well-prepared transitions, yeah.
Oh wow!
Single
Oh, dude,
slide,
hold on
brother.
one second. We're rerunning this. The significance of the lab frame. Check out these transitions, bro. They're super smooth. Here we go.
Okay.
All right.
There it is. There it is. Yeah.
Are we on track with YouTube here?
Yep. Go ahead. So the fringe shift that we're all familiar with has a preferred direction, which proves a dynamic ether, but in relation to what? And then go ahead, sir. Lab frame and bucket.
Yeah, and everything from Newton's bucket to laser interferometry, the lab frame is the constant. Same concept, the same principles, the same thing. If you're standing still on the ground and you see the bucket spinning, you'll make the right prediction. If you attach yourself to the bucket frame, you will make the wrong prediction. Go ahead, next slide. There's just a couple of quotes from Robert Bennett. I'm going to be quoting on him pretty heavy here, so thanks a lot ahead of time. The lab frame is dynamically unique and absolute. I really love that. That is, you couldn't say it much more succinctly than that. And then many, in fact, all predictions from Earth's frame will be valid. All non-Earth frame predictions will be fictitious. The obvious choice, be a geocentrist. Only predict motion from the Earth's perspective. PhD physicist Robert Bennett.
What
Nice,
an
that's a good
awesome
one.
quote.
So here we're just going to look at Faraday's law of induction. So I'm sure everybody can read that equation at the bottom there. Totally kidding. We're just going to go over that because I had to go over this and look at it because I kind of want to know what I was talking about. So a little backwards 3 there, the epsilon is equal to d phi over dt. And so this d phi is a magnetic field in flux, okay? So the phi just stands for magnetic flux through the circuit. And the dt there is the rate of change of magnetic flux with respect to time. So this induced electromagnetic force, the E here, how are we breaking that down? It's equal to the magnetic flux with the rate of change of magnetic flux over time. Okay, so this magnetic flux, this is a change. This is a movement, is what it is. But here it is, the question again, movement in relation to what? Next slide, please. So here we're going to talk about the Faraday paradox a little bit. And this is from nature.com. A novel experiment has been devised shedding new light on the phenomenon of unipolar induction, also known as Faraday's paradox. In particular, the question of the field co-rotating with the magnet or remaining stationary remains unsettled, and supporting evidence exists for both positions. The results show that the closing wire, that is the point here, the closing wire needs to be considered as part of the problem, which enables the apparent paradox associated with this phenomenon to be resolved. However, it remains impossible to tell if the field co-rotates with the magnet or if it remains stationary. And here's what Robert Bennett has to say about this apparent solution. The solution is faux. Bluetooth can replace the connecting wires. I get a kick out of that one. So anomalies disappear in the alpha model when Q moves relative to the lab frame in the presence of B. So in other words, there is no paradox in the alpha model. When a magnet moves or there is flux relative to the lab frame in the presence of a conductor. Next slide, please. So what is otherwise a paradox becomes coherent and logical within an alpha paradigm. And here's another quote from Robert Bennett. So the Faraday paradox is simply solved by asserting the lab frame as the only frame in which the laws of Maxwell make valid predictions, an assertion also true for Newton's laws. And so the description of the Faraday paradox, if nobody knows, you want to just back up 1 second real quick. So here we have on the left-hand side of this little diagram here is when you spin the conductor against the magnet, just the conductor, you'll get a charge. If you spin the conductor and the magnet together, as shown in the center of the diagram there, you will also get a charge. But for some reason, when you spin just the magnet against the conductor, you won't get anything, which is what is the crux of Faraday's paradox. Okay, next slide, go ahead. So in all ways that we can test and measure, the Earth is at rest. I made this picture because I think there's almost everything in it that we can use to test and measure the Earth. You've got light, you've got a plane, which is aviation itself. It's got GPS on board, no doubt. And I'm pretty sure those missiles probably have a ring laser gyro on them. Next slide, please. So what does it all mean? You know, I'm reminded of something I heard Terence McKenna say when he said one of his philosophy teachers told him, I'm not just going to tell you the truth. I'm also going to tell you what's so great about it. So what's so great about it? Well, I think that the implications stretch far beyond mere science, but that's your journey. May the light of wisdom guide your path. And I'll conclude here with one last quote from Robert Bennett. Now, modern science agrees with all these tests, but assumes/insists that other inertial frames exist besides the Earth, like the sun, moon, planets, or solar system barycenter. But any frame moving relative to Earth will predict different forces and energies than actually measured, making the Earth the only cosmic location truly at rest, as Scripture always asserts. PhD physicist Robert Bennett. And I just got one closing slide here.
Wait, I have a
Just
question about Faraday's. Oh, sorry, you're already done.
Yeah, it was just a huge thanks to Robert Bennett, Alan, Shane, Stone, and everyone at Aether Cod. Much love and respect.
Nice. Yeah.
Yeah,
So,
question?
what's the significance of it working, of the paradox applying when it's when both are rotating, but not when they're not rotating, or when they're right next to each other?
So,
Ooh.
Alan, take it back to the 3-shot slide.
Yes, sir. Great question, Shane.
That was it right
Right.
there. Yeah, man.
Yep. So in the middle, what's the
because
significance of that?
I can tell you what I think, and then I don't know, maybe Bennett has a different answer because I was thinking about this and there is a lot of nuance to this. So my personal opinion is that when you spin the conductor, the reason that there's no magnetic flux is because the center of the magnet isn't moving at all. So even if the field lines were rotating, you wouldn't be causing any flux because the center of the magnet isn't moving. And in my opinion, that's what has to move. Maybe somebody has a different answer, you know? Because you're not
And
really moving the magnet if it's spinning, especially along an axis.
another way to interpret that is that instead of being fixed to the center of the magnet, the part where it would actually be kinematically stationary and dynamically, you could say that the field lines are fixed to the ether itself, or like the absolute frame. So
Yes.
they're not
that's
attached. They're not attached to the physical object. So like relativity needs it to be manifested like inside of the object and attached to the object. And then so if that were the case, when these are rotating and co-rotating with one another, when these field lines get plucked, so to speak, they should produce that EMF. And in the situation where they're co-rotating, relativity predicts no relative motion between them, yet yet there's EMF. So that shows that they're not fixed to the physical magnets themselves. And that they can't have that interpretation because it begs the in question, with respect to what, as they say.
yeah. I think it heavily implies the ether, right? An energetic background for which it to move through. Otherwise, you don't get anything.
Well, I mean, you can't even have a continuous line of force without that anyway. Like one of my favorite things that you ever introduced me to was that Eric Dollard video where he scrapes the magnetic field lines with the
I was
speaker.
just gonna say that. I was like,
It's
what's
like
the next thing I was gonna say?
it's like
The way that
it's
you
like yeah,
answered it,
dude, that's
yeah.
just an interaction of discrete packets that mean nothing with respect to
You hear
nothing.
that? That's discrete packets bumping into each other in the sonorous sound of.
Yeah.
I got a quick question about Newton's bucket, if you don't mind. You said when we observe the bucket, we predict the vortex, but when we're in the bucket frame, our prediction is wrong. So what does that mean? What's our prediction? What would be our prediction that would be wrong?
Let me show you a more detailed slide with the math, but basically it's the equation for centripetal force. No, centrifugal force. So when you apply the motion with respect to the lab frame, you predict that the bucket's in motion and then there's going to be a vortex produced by the motion. If you were to take the reference frame of the bucket, you would be stationary in the bucket, but you would see the lab frame moving counterclockwise to whatever the rotation was in the lab frame. So because you're not moving, you would predict that there's no force when you solve your centrifugal equation, and that it's not going to be valid because you're looking at curved water. So like if you were going to predict based on your motion if there was going to be curvature applied to that water or force applied to that water, you would make the wrong prediction.
Gotcha. So
No.
it shouldn't be vortexing from the bucket frame, basically.
Well, they
It
can't
should be
they can't explain why it is. Yeah.
right. Okay, I think I get that.
Yeah, excellent presentation, dude. I also like the heavy visuals you went with. That was excellent. Not to mention the transitions, which are definitely cool.
Dude, yeah, that was awesome, Colin. Colin, you killed it, man.
Could you go back to that same slide?
Oh, thank you.
I like how you complained about learning as if learning wasn't the whole journey. I thought that was funny.
This one right here?
Like you don't love it.
Yeah.
Oh, you
four
have the
about
equation
3-4
in there.
frames to the 3-shot slide. Forward a couple slides.
Yep. Say when.
Fast.
This one.
There you go. Yeah. I have a whole other interpretation. I'm sure you might guess
Oh yes, go ahead.
about what's going on here. When I look at how this paradox quote is described, it strikes me that the entire analysis has been criminally condensed and dramatically oversimplified. And I think in turn, a couple things about this are being overlooked. When we look at the magnet's orientation relative to the axis of spin, like you're saying, the reason no EMF is produced because the flux lines aren't being cut by the conductor. Well, that's actually true in all three cases, except that there could be some noise, there could be some ether influence because you are moving the conductor. And I think whether or not the magnet is moving is irrelevant. And that's because of the direction of spin of the magnet itself being axial. That the z-axis, so to speak, the up-down here, it would be the axis around which the magnet is spinning, and south is just occupying its own space as it spins. North is occupying its own space as it spins. If you were to rotate this magnet on its x or its y-axis, instead, those being the axis going across the page and the axis coming in and out of the page, like you're flipping a coin. If you did that in any of those where you're moving the magnet on the different axis, you would get EMF going through the conductor. And that is because the lines of force would actually be cutting the conductor. Now, the problem here, I originally picked up on it because during the analysis or the description, the opening description in all the textbooks and even how it was just covered tonight, nothing is quantified. It's just logically produced. Is there EMF? Is there not EMF? And I think this is where we go wrong in the analysis. And we draw all kinds of other conclusions based on an incorrect analysis, much like Newton's bucket in a very certain sense. I hope you guys are following me here, that if we were flipping that coin, the conductor would indeed, whether it's moving or not, would produce an EMF down the axis. Am I making sense? Or have I just blown everybody out of the water here?
No.
So you're saying your analogy is comparable to Newton's bucket?
Yeah.
Yes.
But
and
also
that is very
with
cool.
regard to the motion of the magnet itself. You see in the logic, the logic chart that we're looking at here, again, nothing is quantified. What's the spin? How precise is the spin? Is this just textbook where it's exactly a perfect cylinder, exactly block line cut exactly through the middle of it, which I'm sure is actually quite rare in a magnet you would produce polarized through its thickness the way that we see here. And I don't think it matters whether the north is on top or the south is on top, as they are all detailed the same here. You know what I mean?
No, haven't people done this with an oscilloscope and like measured it?
Well, that's the thing. They've done that, and what you're looking at is exactly like what I've just detailed. That there could be imperfections in the construction of the magnet itself, such that it is not purely cylindrically split like this, absolutely perfectly magnetized exactly through its middle, exactly orientated to the flatness of the top surface of the magnet, parallel to it. You know what I mean? That there are imperfections when we drop things through the Curie point and we magnetize things in the presence of a magnetic field. There could be something slightly out of alignment, even by a degree or two, such that afterwards, when you spin it, you're not going to get like what you expect on the far right. That there actually would be some EMF produced because it's actually changing slightly the lines of flux, which is why I personally am totally unsatisfied with the analysis of this paradox because nothing is quantified. How much EMF is produced in case A, case B? You know what I mean? And if you were to flip it on the x-axis, the magnet, or the y-axis, the magnet, in those two cases, either of those two cases, how much more EMF would you be producing? And I think that is the nature of the problem here. Sorry to poop on your party, guys, but to me, this doesn't actually make physical sense in terms of the analysis and the geometry of the analysis. That's the major problem that I have here.
Oh, well, no, you didn't poop on anything.
Well,
It didn't.
Okay,
It doesn't
good.
make sense because people have measured that amount like that you're asking for, and then you're saying that
But I've
maybe
never
that,
seen
and
anybody
then,
quantify this.
and then you're saying
You
that
know,
maybe
like,
that, and then you're saying maybe that amount was due to statistical error in the magnet or whatever.
well, production error, maybe. Or how it's situated on its axis, or how it is actually spinning in physical space. Is that absolutely perfect? And what is
Yeah.
the spin rate? That kind of thing. I'm just not satisfied with the paradox itself.
No, you're good. You didn't poop on anything.
Okay.
Dude.
Okay, my 2 cents. But by all means, on with the party, guys. Let's keep
no,
going then.
I
But
mean,
that's
in
what I
my
see here.
reading, this has been a point of contention. Even in mainstream scientists argue about it still to this day all the time, and that there have been papers published to say that the field lines co-rotate with the magnet, and papers published to say that they're stationary with the lab frame, basically. And so, yeah, this is,
Mm-hmm.
I just colloquially for here, obviously, I mean, I don't think you disagree with the fact that, the magnet moving in relation to the lab frame, it, makes the right prediction here.
Well, that's the thing. In these three cases, whether the magnet is moving is not relevant. It's only whether the conductor is moving. You see that the first two, the conductor is moving, so there's EMF. The third one, rather, it's not moving, so allegedly there's no EMF produced. When I think, actually, in the third case, when the magnet is spinning, because we can't produce a perfectly sliced, perfectly block-lined magnet the way that it's illustrated here, and what we assume it to be in the perfect scenario, we can't actually really do that with certainty, and that's a hard thing to determine after you've bought the magnet, after you've got it in your hand. Do you know what I mean?
Yeah, I think I was following you there. Yeah, like I'm no physicist, so.
No, just I'm trying to throw a little common sense at it and seek a more in-depth analysis of what really is going on here in terms of a real experiment, in terms of a real replication, and what Plenum 88 did, and et cetera, et cetera, et cetera. All the people down the line who have done this. Action Lab, like I was pointing out to you last night.
Yeah, I watched those, definitely. No, I appreciate your critique, Stone.
Cool.
Dude, that's an awesome presentation. Especially with what you present can provoke such thought-inspired conversation. It's probably a good sign.
The other addendum point that I would put on it is that a reiteration of some things that I've said on some previous reading nights about 10 to 12 months ago, depending on the one we're talking about the misinterpretation between lines of force and lines of flux. When people say field lines, I wonder which ones they're actually talking about, because they're
That's a good
the
point.
opposite thing.
Yep.
Right?
I remember that.
One's
I remember that.
perpendicular to the other, and I was just thinking
Right.
about that early, when we were talking about it.
Yeah, just to keep those in mind when people think about this and try to reason it out. You really have to have all of the facts and frankly fully quantified values to analyze this coherently.
Yeah, when you look at when you go to like the Ken Wheeler or the Fractal Woman, what are those things called that they do with the magnet? I can't think of the name right now. Where they show the flux lines.
ferrofluid?
Yeah,
Yeah.
the ferrofluid thing. When you're looking at that through the thing, that's not the force lines. That's the flux lines. The force lines are perpendicular
Precisely.
to that.
And the density of the flux lines is the color. Exactly that.
Dude, shout out to Fractal Woman. She taught me that.
Very cool.
But yeah, that's a super important concept. And like, so what that means is if you were to drop iron filings over the top of that that configuration, they wouldn't line up with what you're looking at visually. They would align perpendicular to it. So keep that, like the Stone's saying, to keep that in mind. And then question about the Faraday paradox and the EMF produced. Is the EMF produced not proportional to the velocity of the rotation? And if it is
of the spin? Well,
Yeah.
yes, but it's not the only proportionality to regard. It's the imperfection in the magnet as well. The asymmetry of the assumed symmetry of the magnetic lines of flux here.
Yeah,
That we can't really.
I mean,
And even the conductor itself, in terms of its own internal friction, its own hysteresis pattern, we're not that good at making perfect cylinders that are completely homogeneous. You know what I mean?
no.
And
If
we
it's
can't know.
proportional to the velocity and then like plus or minus some statistical error, I mean that's kind of
Yeah.
that's-
But again, that is still telling you might be just only be giving you the coefficient of imperfection within the strata itself. You know what I mean? You'd have to replicate it many times with many different materials made, maybe even made with using different methods. One could be a depositional, like a cast, or one could be forged, et cetera, et cetera, et cetera. It just needs to be a little more coherent than what is presented in the textbook.
Yeah, and then well, I mean, on top of that, the other theory just predicts no thing at all. Like the one time that they predict, well, the one time that they'll openly be like, we predict no fringe, no EMF. There's still EMF proportional to the velocity there.
Some
So
background, yeah.
yeah, so I think that like overall it shows that the field lines, however you conceptualize of them, are fixed with respect to the lab frame. And like Colin was saying, making the predictions of what's going to produce EMF based off of the lab, with respect to the lab frame, is going to make the correct prediction. So I think in that regard, I think that aspect of the paradox is the, uh, the important aspect of it.
Sure. Alrighty, on with the show.
All right, Colin, thank you so much, dude. That was an awesome prezi, bro. Absolutely
Hey,
crushed
thanks.
it. There was
Appreciate it. I hope everybody got something out of that.
yeah, it was great, dude.
Thanks, Colin.
That was awesome.
Thanks, Bros.
All right, we will now returneth to the paper from Shankland and the boys, again covering the Michelson-Morley situation, where they were saying that the lab frame is moving at 30 kilometers a second with respect to the ether, and when they went and took the measurements, it turned out to be a much less than what they expected. And so this is now we're going over how they analyzed it and interpreted how to make the measurements go away. Because even though they were smaller than what they expected, they were larger than what they could chalk up to air normally. So this is a way after the fact analysis. All right, so introduction. The null result obtained by the Michelson-Morley experiment at Cleveland in 1887 was the culmination of the long 19th century search for an ether and proved to be a major incentive for the theoretical developments made by Lorentz, Fitzgerald, Lamore, Poincare, and especially Einstein. The crucial significance of the Michelson-Morley result stimulated many repetitions of the experiment during the next 50 years, especially as the implications of the theory of relativity unfolded. All the trials of the experiment, except those carried out at Mount Wilson by Dayton C. Miller, yielded a null result within the accuracy of the observation. Miller's observed fringe displacement also were very small, being on average of only 1/13th of those predicted by the ether theory of 30 kilometers a second. So keep in mind here, there's a lot of like contextual reframing of this to make it seem like the ether theory predicts this. Not only does the ether theory predicts this, but heliocentrism predicts this irrespective of any ether. So there should be, if the motion is real, there should be a way to detect it. And so removing the ether from it and reframing it contextually like this is part of how, they've gotten away from, like, that's the important parts of this paper, not the fact that what we're going to read is going to be very shaky in terms of providing an actual substantial refutation to the measurements that were made. So, however, these small residuals receive no adequate explanation, and since interest around them has continued, it seemed desirable to make a rather detailed analysis on the observational material. Michelson-Morley had originally planned to repeat the experiment at intervals of about 3 months throughout the year, and thus allow any possibility that the Earth's orbital velocity at one epoch might fortuitously combine with the motion of the entire solar system through space and give a small resultant velocity to their apparatus. However, after completing the July observations in 1887, they did not return to this problem in the completion of the ether drift experiment for all the epochs finally carried out by Miller during the years of 1921 through 1926 in Cleveland and at Mount Wilson. Miller's Mount Wilson experiments were conducted at intervals from April 1921 through February 1926, being interspersed. Being interspersed.
Were you interspersed?
Oh, interspersed. Thank you. With and followed by the extensive trials at Cleveland. In February 1921, the interferometer was set up at Mount Wilson, and Miller made numerous observations during the period of April 8/21, 1921. These data indicated a small possible periodic shift with an average harmonic amplitude of about 0.04 fringe, but Miller suspected that temperature affected the magnetostriction in the steel base of the interferometer as it rotated, and an Earth's magnetic field might be the cause. Accordingly, he designed a concrete base for the interferometer, which was cast at Mount Wilson in October 1921. Undoubtedly, the greatest incentive to continue the experiments came from Professor Albert Einstein, who visited Miller at Case in May 25, 1921, and urged that further trials be made to remove any possible doubts concerning the earliest results about the experiment. That's true. I think that quote from the paper where he talks about experiment being king, I'm pretty sure that comes from a quote from an interview where he's replying to the Miller data. I'm almost positive that's where it comes from. That's a pretty famous quote there from that. But anyway, Miller conducted a series of observations with the concrete base interferometer from December 4 to 11th on 1921, but with a rather discouraging result. Much of the time, the interferometer behaved poorly, and the fringes, often unsteady. Temperature variations near the instrument were troublesome, and the vibrations caused by high winds made observations entirely impossible. However, last December, on 9/11, or December 9 through 11, 1921, 13 sets of readings comprising of 153 complete turns of the interferometer were made under favorable conditions, some of them excellent seeing. These data gave an average of a periodic amplitude of only 0.04 fringe, nearly the same as the April 1921 results with the steel base interferometer, and Miller concluded that the effects are probably due to the instrument. This is the end. Or all effects are due to the instrument. This is the end. So shortly thereafter, he dismounted the apparatus for Cleveland to Wright, where he reassembled it in a basement at the Case Physics Laboratory. Since about 1921, experiments of both steel and concrete bases of the interferometer gave essentially the same results. Miller concluded that the magnetostriction was not the cause of the small periodic observed shift. However, since the mechanical rigidity of the concrete base instrument was less than that of steel, a conclusive argument could not be made. The magnitude of the magnetostriction effect is marginal. Nevertheless, it cannot be ignored since it would produce a second harmonic fringe displacement. Professor G. Jews, in his repetition of these experiments in 1930 at Jena, used a fused quartz base in his interferometer because he concluded that the magnetostriction of steel or Invar base would be excessive for the precision he expected to attain. After the 1921 trials at Mount Wilson, Miller probably would have abandoned further work on the problem, except for his visit to Case made by Lorentz during the following spring. During this visit, he discussed the Mount Wilson observations and encouraged Miller to continue the experiments. Shout out to Lorentz, a true homie. From the time that the steel base interferometer was set up at Case in 1922 until it was returned to Mount Wilson near the end of the summer in 1924, Miller carried out many experiments designed to test the improved performance of the apparatus. He established an order of magnitude in the fringe shifts produced by unequal heating of air in optical paths of the interferometer, by varying the speeds and reversing the direction of rotation of the instrument, by various adjustments and centering pins, or adjustments of the centering pins. He also used different light sources, including sunlight. Many of the Cleveland trials from 1923 to 1924, especially for which the data sheets record the best, quote, seeing conditions for the interference fringes, the periodic effects are very small. These data were not analyzed in detail by Miller, and he considered them only preliminary to the other work at Mount Wilson. His other 19 sets of the observation made from August 23rd to September 4th in 1923, and 42 sets of data taken from June 27th to July 24th, 1924, including those made in sunlight, for which the interferometer was in the best adjustment and had the fringes and the fringes were often noted as, quote, good or excellent, constitute some of the best data obtained by Miller's interferometer. These 1923 and 1924 Cleveland results include a Table 1 which summarizes the important trials of the Michelson-Morley experiment. After the completion of July 1924, the trials in the apparatus was returned to Mount Wilson, where it was again set up by the observation hut, which was moved back some distance from the canyon edge to reduce the effects of wind. After a considerable number of preliminary trials, the extensive series of observations were made by Miller at 4 epochs: March 27th through April 10th, July 1925, July 24th, August through August 8th, 1925, September 10th through the 23rd, and February 3rd through the 12th in 1926. The readings of the fringe positions were taken at 16 azimuth positions starting from north, measured clockwise. A data sheet usually contained readings of 20 turns of the interferometer, although some contained greater or lesser amounts of data. For the analysis, Miller averaged 20 readings of each azimuth and then applied a linear correction for the fringe drift that averaged the that averages close to the that so that the averages closed at a periodic function in the 360 rotation. Furthermore, a constant was then subtracted from the averages so that the mean was 0. These adjustments were plotted in the azimuth connected by straight lines to give a graph for harmonic analysis with a Hernici machine. A sample of the data sheet which presents details from this reduction method is published in Miller's second reference here. Miller's harmonic analysis of these curves yield amplitudes and phases for the first 5 harmonics. The second harmonics provides the parameters needed for computing the presumed ether drift. The phase obtained from this analysis were never capable of being fitted into a logical relationship corresponding to an oscillation about the north point of course, the sidereal day. As reported by Miller in citation 2, the axes were displaced from the meridians as follows: February 10 degrees to the north, or 10 degrees to the west of north; April a displacement of 40 degrees east, and for August 10 degrees east, and September was 55 degrees to the east. This azimuth anomaly has been the greatest obstacle as to the acceptance of the small periodic amplitudes reported by Miller having reference to an ether drift effect. Singe and Gardner have developed a theory of the Michelson-Morley experiment, including the effects of acceleration, which is not inconsistent with the occurrence of the azimuth anomalies, such as found in Miller, but furthers the predictions of his theory that disproves the experiments by Ditchburn. Statistical analysis of Miller's data. The data collected by Miller have recently been re-examined with a view establishing the importance of statistical fluctuations and physical causes of the small periodic effects which he obtained. Consider the first individual data sheet. It is generally agreed that an experienced observer with keen eyesight, such as Miller, can estimate the fringe position to about 0.05 fringe, which may be regarded as the least count of the instrument. This personal factor will introduce variations of the data in addition to those arising from another cause. Prominent among the latter possibilities are mechanical variations and the bending of the interferometer as it rotates, temperature disturbances producing both a drift of the fringes and a periodic change in the magnetostriction, which would cause a periodic drift. A typical datasheet contains entries of 16 columns for azimuths and points of the instrument and 20 rows for each complete turn of the interferometer. Under ideal conditions, no ether drift nor statistic or random effects present, and all entries in the table should be identical. In the few sets taken from Cleveland in 1924, this is nearly the case. Usually, however, the readings show a considerable variation having a general character from random fluctuations superimposed on a irregular drift. A standard analysis of a variance technique may be used to examine the degree of randomness in the datasheet. Let X be the fringe reading in the position of X bar I be the average of the ith column of data, the azimuth position of the interferometer. Furthermore, let X bar be the average of all 320 entries X sub ij on the datasheet, where X sub ij and hence the averages have already been freed from the linear drift through the whole fringe of the system in the same manner as Miller did. Suppose that these 320 values be considered as a random sample draw from a normal population. Furthermore, suppose an arrangement into the columns and rows is a random one. A statistical theory shows that the variance of X may be resolved in a contribution due to the variation of the individual entries of the column and the column means of the contribution due to the differences between the column means and the mean of the whole assembly. A measure of the relative significance of these is given by the statistic F, defined by F 360 times 19 over 15, and then the summation over more summations of all the other data sheets. Under the hypothesis of the randomness of the abnormality of population and the probability of F for a given sample will exceed a given value has been tabulated. For the number of degrees of freedom involved in the present data theory shows that the probability of obtaining a pure sampling fluctuation of F being greater than 1.71 is only 0.05. The probability of obtaining F being greater than 2.21 is only 0.01. These probabilities are the accepted limits for rejecting the hypothesis that the array could be that the array could have arisen by sampling fluctuations in a normally distributed population. When a large number of data sheets are analyzed, one would expect 1 out of 20 to exhibit F being greater than 1.71. If the population of the data sheet or samples consist of randomly fluctuating data, if many of the data sheets lead to an F value greater than the limits quoted, it is highly probable that some systematic effects are present in the data. Figure 1 shows the frequency of the distribution of the F values computed in the data sheets, together with a theoretical distribution of F of the appropriate number of degrees of freedom involved. It is apparent immediately that the observed number of large F values far exceed the number to be expected on the basis of random sampling for a normal population. In fact, 36.5% of the F values exceed the critical value. 1.71 and 25.3% of the exceed the value of 2.21. The analysis indicates that the fluctuations in the column means that they cannot be attributed entirely to random effects, but the systematic effects are present to an appreciable degree. A second method shows that the periodic effects observed by Miller cannot be accounted for entirely by the random statistical fluctuations in the basic data. 5 representations of the data sheet's unprocessed data were subjected to the auto-correction analysis. These sheets were selected with the typical Mount Wilson data. Miller had deduced from them a second harmonic amplitude of 0.021, 0.045, 0.059, 0.82, and 0.123 fringes respectively. Thus they embrace near the entire range of the second harmonic effect, which is under examination. In the 3 data sets, numbers 42, 49, man, that's not it either. 42, 75, and 79 in table 2, a strong period of 8 second harmonics were found relative to those periods 4 through 12. However, in the other 2 sets of data analyzed by this method, the period of 8 was no more prominent than the other periodic components. These predicted a true magnitude of the systemic ranges, which the effects greatly or varies greatly with the conditions observed, as would be the case caused by logical disturbances or by local disturbances. A summary of the pertinent results regarding the period of 8 is given in Table 2. The units in the units in the table are fringes. Column 2 is the amplitude of the second harmonic as obtained by the Horinsky machine by the harmonic analysis. Column 3 is the amplitude deduced from the correlelogram and contains whatever random fluctuations are in the data. Column 4 gives the amplitude with the random effects removed. It is again apparent that the random statistical processes contribute considerably to the periodic effect when the small but the larger amplitudes are relatively unaffected and cannot be explained in this manner. So consider that the actual harmonic analysis of the Mount Wilson data, Miller's harmonic analysis, records the amplitude and distribution of the first 5 harmonics for which the relevant statistical parameters are summarized in Table 3. The values of the mean amplitudes of A bar, K are given here. The standard deviations have been computed directly from his data cards. Altogether, the 4 seasons, 306 data sets were used. There is no significant seasonal variation of the mean amplitude of the second harmonic. The values of A2 being 0.042, 0.49, 0.38, 0.45 of fringes for April 1925, July, September, February 1926 epochs, respectively. Tables 3 indicate a clear dominance in the first and second harmonics over the others in the harmonic analysis, while the third and fourths and fifths harmonics have an order of magnitude equal to the standard deviation. The first and second harmonics are considerably larger. However, the average A2 here is only 1/13 of the value expected by the basis of usual ether drift hypothesis, assuming that they're going to get the ratio of 30 kilometers a second instead of whatever that is they measured, which comes out to be 8 kilometers a second in the Wilson data, 8 to 10. Let's see. It is interesting to note that among the trials which yield an unusually large amplitudes of the second harmonics in the fringes that are greater than 0.08 fringe, 14 out of 17 were made either at the beginning or at the end of the series of the observations or were made under the adverse conditions noted in the datasheet. The question is, what part of the observed average amplitude for the second harmonic deduced by the harmonic analysis may reasonably be attributed to random statistical fluctuations in the data? Let's sets of observations selected from random populations, which is normally distributed and plotted as ordinates with its order number, drawing as in abacus. Suppose a harmonic analysis is made at each set, and then the probability of the amplitude of the kth harmonic, A to the K or A sub K, is chosen at random among the sets and will lie between A and A plus dA. And that's given by this equation here, where N is the number of observation analyzed and H is the measure of the precision of the population. From this, the mean amplitude of A sub K, often designated M of A sub K, and the standard deviation of sigma A sub K are found to be respectively given by this equation here, independent of K. The tabulation of the values of X bar is irrespective of the azimuth I, which Miller made in his harmonic analysis, which indicates approximately the normal population with a standard deviation of 0.05 fringe. Thus, this extreme case, if all the variations of the data used for the analysis were attributed to random fluctuation, one would expect the fringes to be A sub K equaling 0.023 of a fringe, with a sigma of that being 0.012 of a fringe. On the usual assumption that the squares of the random systemic contributions to the amplitude add to the produced of the amplitude add produce the observed statistical fluctuation of A sub 2, and it appears that no more than 15% of the second harmonic amplitude can be due to the statistical causes. This is in accord with the result of the autocorrelation analysis and leaves the average of the residual amplitude of A sub 2 equaling 0.038 fringes to be explained in other ways. Thus, there can be little doubt that the statistical fluctuations alone cannot account for the periodic fringe shifts observed by Miller. On the other hand, the presence of the periodic effect in column X bar sub I may clearly demonstrate in a way which again exposes the incompatibility between the phase anomalies already noted in the usual kinematic accounting of the ether drift experiments. When the X bar sub I for the 20 sheets of July through August at Mount Wilson in 1925 data are plotted as a function of the azimuth index, the result is shown and given in figure 2. These sheets have been chosen as so to take the 24 hours of the sidereal day. They are obviously considerably scattered in the X sub I at each azimuth position, but the averages values calculated at each index show the marked second of the harmonic effect. The large field of circles represents X sub I with the brackets around it. Similar results have been found with 3 other epochs in the Mount Wilson observations. Now let these values of X sub I for I equaling 9, 10, going to 16 be averaged with those of I in a series going from 1, 2, 3 to 8. And when this is done, a smooth curve will be drawn through the points, and the result of the curve will be labeled July. Through figure 3, similar curves for the other epochs will also be shown in the figure. 20 data sheets representative of sidereal times were used for the analysis. Note that the resulting periodic fluctuations have amplitudes between 0.02 fringes and 0.03 fringe. But they differ in phase, practically striking the difference between February 1926 and the others. Striking is the difference. It is, on the other hand, possible to calculate in a rather straightforward way that the fringe shift pattern averaged over all the sidereal times to be expected on the assumption of absolute motion of the Earth through the ether on the basis of the usual kinematic considerations. Oh, no way. Let V be the vector of Earth at a given epoch towards the apex of the celestial coordinates, which are given by alpha, comma, delta. Let V sub P be the projection of V in the plane of the interferometer, phi be the latitude of the observer, and psi be the azimuth of the telescope arm of the interferometer measured from the north point through the east. Then the calculation shows that the same delta N sub AV of the fringes, that new average of the fringes over sidereal time is given by equation 1. Since phi is a constant and delta is fixed in a specific epoch on the average fringe shift of a second harmonic results, clearly the angle psi is equal to 2 pi times I minus 1 over 16, and the computed delta N average corresponds to the observational equation here. Thus, the direct correspondence between these curves of figure 3 and equation 1, and no phase anomalies of any kind is observed. In figure 3, observed in figure 3 are permissible, sorry. The 4 curves have a common maximum or minimum at I equals 1. The only amplitude may be different at different epochs. Yeah, no way. Others, so corresponding to like a solar movement. Let's see. This criticism is, of course, only different from the form objected raised by von Lau and Thuring. Both authors point out that the Lorentz criteria for the Lorentz criterion, which requires the mean value for the velocity over the sidereal day to be a vector in the meridian, is not satisfied by the results on the Mount Wilson observations from 1921 and 1925. Theoring shows that a single daily pattern of these observations cannot be made to coincide with any of the daily visible derivations, or I'm sorry, pattern derivable from the usual kinematic theory of variation of delta. The present form of the criterion, if it may be designed, is perhaps more convenient when a large amount of data is checked for consistency. In the interpretation of Miller's hypothesized, or in the interpretation of the observations, Miller hypothesized that for unknown reasons, the daily swing of the vector v sub p might be symmetric about some line other than the meridian, and the angular deviation from the meridian be permitted to vary from epoch to epoch. In terms of Figure 3, this is simply a deviation of the first maximum from the north point, but the angles in our figure differ considerably from those found by Miller. Actually, Miller drew the curves A versus theta, where A equals the azimuth of the vector v sub p is max, and theta equals sidereal time. For each of the four epochs determined each of the four epochs and determined his anomaly from what was called the he called the own axis of the plot, meaning, and some of the meaning of that is obscure. With respect to absolute space, the meaning of this is obscure. Contrary to the expectation, it does not designate the horizontal axis through the centroid of the observational curve, since the ratio of the upper and the lower area is found to be 1.3, 1.7, 1.4, and 0.6 respectively for the four epochs. Under these circumstances, little significance can be attached to the remarkable agreement between the values of alpha and delta computed from v sub p versus the theta curves on the one hand, from a versus theta curves on the other hand, as presented in tables 1 and 2, the references of in reference to part 230, page 230, in reference to page 230. Got it. The second method of computing these theta values, at which A passes its own axis and the quantity A max is both taken from curves. Both parameters depend, of course, on the choice of its own axis, but the first of them is extremely sensitive to the choice of furthermore, is directly equal to the right ascension of the apex given by alpha. Hence, even if one were to accept the azimuth anomalies as an unknown effect to be explained by a more refined theory, any numerical results based on the method of averaging the groups of v sub p values in order to obtain the 20 v sub p averages, roughly equidistant in theta, and use these 20 points as true representatives of the curves sought cannot be considered a statistically satisfactory because of the enormous scattering of the observational results. However, a more refined redetermination of these parameters enters the first method of computation, and that did not justify for us to follow that reason. If the azimuth anomalies are accepted, and equation 1 is established with a simple connection to equation 2 between the maximum of the fringes observed, the average observed during the epochs of a function given by f delta phi naught, whose deviation with respect to delta can be shown to vanish for degrees being equal to 90, now changes only slightly from epoch to epoch, which makes it feasible to satisfy approximately by contrast the vector v for all epochs. However, the vector must contain a variable contribution to the orbital motion of Earth. This has to, huh? This may this difficulty may be overcome by choosing a cosmic V naught, such as the V naught is much less than the V orbital, and the delta naught is not far from 90 degrees. But a further obstacle arises, namely that delta equals 90, where f delta becomes simply a squared cosine of phi, where a squared is a constant completely determined by the geometry of the wavelength of the interferometer. Thus, the magnitude of V naught plus V orbital cannot be chosen freely. A reduction factor becomes necessary to make it so that delta n is equal to k times the velocity vector squared times f delta, which is their celestial coordinates, where k is about 1 in 20 of Miller's cosmic solution. It seems to us that the basis of the discussion that the internal consistency of the cosmic solution is not so great to surprise that it appears at first glance. It certainly cannot be. It certainly is not cogent enough to serve as a logical support for the claim that the half-period effect observed is a true ether drift effect. We therefore did not embark on a statistical recomputation of the cosmic solution, but rather concentrated on the efforts and the interpretation of Miller's observations in terms of the statistical local disturbances as many can be caused by the effects under non-uniform temperature perturbations and observed in the hut. All right. Does anyone want to take over?
I just got back into the room. Possible mechanic effects? Oh, great. Actually, I wanted to address something now that we're talking about that point right there. We did not seize. It's just that last paragraph you just read seems to us. You mean you, the author? The discussion of the internal consistency of cosmic solution is not such a great surprise as it appears in the first glance. Not cogent enough for who? As logical support, what kind of logic are you considering? This is such very spurious dialogue in here. And because it's not logically supported, we didn't actually look at that recomputation of the cosmic solution. We just look at the systematic noise causes that could be the reason the data is what it is. We didn't look at the one which could be the actual explanation for the readings. We didn't bother, is what he's trying to say there. And I find it most conspicuous.
And while I was reading through that, it kind of sounded like they were half statistically ruling it out while also saying that under different analysis, they couldn't rule it out and it didn't fully account for everything. So it sounds like they haven't really made any headway so far.
He's been nailing it down flat as a non-possibility since the very beginning. If you want to scroll back up and start like right at the top here with table 1 on document page 2. He starts to describe what these columns mean in terms of the trial. Okay, that's figure 1. We want table 1. Keep going up to document page 2. There it is. Okay, so my focus here is on what's going on in the last 3 columns, where he talks about 2D over gamma, V over Z squared, and the amplitude measured, right? And the ratio between those 2 columns is really what we're looking at. And you can see that it's numerically inconsistent because of what he's done with the representation of these values. Take 1887, line 2, Michelson-Morley, sub B. The 2D value is 0.4. The A value is 0.005, but the ratio is somehow 40 to 1. That's because the 0.4 is actually 0.2. Because that's 2D over gamma. And the A, the alpha, is just an amplitude. You know what I mean? That it's double the value. So you would either have to cut the 0.4 in half or double the A to come out with a ratio of 40 to 1. It's misleading from the beginning.
Did the old classic?
Can you guys see that?
Did the old ratio switcheroo? No, I would have never noticed it, but thank you for pointing it out.
So what he's done there is he's just completely misrepresented the data by a factor of 100%. Just right there.
Respect.
Right off the top of the analysis.
Just
Isn't
a
that
clean
awesome?
just a clean
Okay.
100 off the top.
Yeah, yeah. And I also liked table 2, and this will be at the bottom of doc page 4. Right column, table 2. It's only 5 lines to the data. Sheet 15, 23, 79, 75, 42. Bottom of doc page 4. So you're way past it.
Oh, document page. That's what you're saying. Got you.
Yeah, there you are. That's the table 2. That's the puppy right there. So what he's done here again is he's got them out of order. Like the first 2 are in order, and then it's last, second last, third last in the list because he's stacked them up according to column 1 or 2 rather. The amplitudes that he's measured from a 50th of a fringe all the way up to just almost an eighth of a fringe, as in 0.021. Pretty close to 0.02, which would be a 50th of a fringe, one to the next. And then 0.123 is almost 0.125, which would be an eighth of a fringe. So he's taking things out of order so that you can't look at it epoch to epoch or, observation time to observation time. You can't intuitively relate anything about sidereal change, anything about, azimuth change or anything about that at all because he's taken them straight out of context almost, just to see how much noise is where. Again, totally misleading. Next page, right column, top right of the page, this figure 2 thing. What he's actually showing you there with the black circles, try scrolling down about 3 paragraphs. There it is on the right. Yeah, figure 2. What he did there was you're seeing azimuth indexes from 0 to 16, and those are the cardinal points on the compass split twice. So you would have 4, north, south, east, and west, being points on the azimuth index, 1, 5, 9, and 13. Here we're looking essentially turning clockwise. Like if you're standing on the ground, your azimuth goes to the right in a positive direction. And this is what the index is all about. He should have used actual azimuth values instead of the column numbers in the azimuth index labeling. Again, totally non-intuitive, hard to understand why things look the way that they look on this graph. So what he's done here in figure 2 with the black circles, that is merely the average of each vertical column's set of readings, regardless of how wide they are, regardless of how much noise is there. That's what he's done. And subsequently, in the next page or so, he's taken those values 1 through 8 and 9 through 16 and superimposed them on each other. So the readings that Miller would have gotten starting at north, going clockwise into the east, and then around to the south by measurement 8, and measurement 9 just past south, continuing clockwise over to the west, and then back up to the north by the time you get to 16. He split these values in half so that 1 and 9 are together, 4 and 10 are together, 6 and, 6 and 12 are together, 8 and 16 are together. So he's literally folded the azimuth chart in half and then took averages of that to see if eastbound is more or less than bound facing measurements. Again, 20 measurements per heading. Are you guys seeing that? That's what he really did with this data.
Disgusting.
So when he comes to figure 3, next page, top left, and he marks one July, that's the solid line of them, et cetera, et cetera. You know what I mean? This is data pushed on top of itself, looking for the quote, second, third, fourth, fifth harmonic. What he's really looking for is migration to the positive and to the negative of 0 fringes. He's absolutely manipulating the data, and this isn't even much dealing with how he's cherry-picked the data. And I've done a little graph, which I'm going to show you guys after we're done reading this thing, so you can get a much better grip on how how totally cherry-picked the data that he's scooped into this paper and has shown you with an upcoming chart that we'll be seeing in a few. So we're at possible mechanics, bottom right of that page. And I'll start reading now if you like.
Yeah, awesome, dude. Thank you
Hope
so much
everybody's
for
caught up on that shenanigans.
thank you so much for breaking down the graphs and making sense of that, dude. Because like otherwise, like it's like reading sign language to me or whatever. You know, it's like okay.
Yeah, my
like
pleasure.
The intricacies
I love
of what
making
they
things
did.
clear, you know?
Yeah, the intricacies of what they did to obfuscate it are hilarious because as I was reading through here, at some point he said something like, if you just analyze it with respect to the epochs in consensual order, you can't explain any of this. So like, yeah, only by folding it up and making it retarded were they able to even try to make it seem like the amplitude goes away. It's a statistical error. It doesn't line up correctly. It makes no sense. It's like, yeah, it makes no sense because you closed your eyes when you were looking at it, dog.
More importantly, that he's taken out the asymmetricality of the data analysis and used that as a reason to not pursue any cosmological influence.
Right.
That it all just must be some kind of instrumentational or noise or temperature-based error. The sleight of hand in here is just so grimy. It's off the chart. Anyway, so let's get back to the reading here. Bottom of 172. Possible mechanical effects. The question may be raised whether some of the local causes which are responsible for Miller's results can be found in the mechanical performance of his apparatus. And this is what it's about, okay? He's completely diverting your focus all completely away from the possible cause. And we're looking at nothing but noise and physical and you know what I mean, internal friction and all kinds of other crap. Miller's papers and notebooks do not offer much pertinent material, but it has been possible to extract some information from his report, from the originals of the photographs published there, and from the interviews with former coworkers. You know, like when somebody who used to work for Trump talks about how life was working for Trump long afterward when there's nothing on the line and they can just say whatever the hell they want. And yeah, we interviewed them. And from interviews with the coworkers, okay, these data make it possible. You know what I'm saying? That's what he did.
Dude, I love that you spotted
did.
that immediately. Yeah, I saw that the other day and I was like, Jesus, dude. They just asked people and then filled in the blanks.
Said, yeah, hey, did you spin the wheel? Oh yeah, how was that? Okay, these data make it possible to investigate the motion and deformation of the steel cross carrying the optics of the interferometer. The cross consists of 4 arms bolted together, each arm being a box structure held together by rivets. The central portion of the cross rests squarely on a wooden support which floats on mercury. Consider the beams B1 and B2, and I don't know where he shows this in this paper at all. He doesn't. I looked for it. I may have just missed it, but he doesn't show these beams. He doesn't show anything about the physical. He just talks about it. Each formed by one pair of opposite arms. So we've got beam B1 and B2 forming the cross, where 1 and 2 are each 2 pieces of box structure. Okay, if the supporting float is horizontal, the ends of the beams will sag under the influence of gravity, somewhat below the level of supported central portion, as in the thing that is floating on in the center. The thing from which outwardly the beams are cantilevered. Now let the cross turn about the beam B2 through a small angle alpha 1. This will cause the beam B1 to unbend slightly, since only the component of gravity normal to the beam contributes to the bending movement. The mirrors rigidly connected to the ends of B1 will therefore suffer small additional rotations in opposite directions about axes parallel to B2. A very small change in the length of the light path will be the consequence of this change in the relative position of the mirrors on B1. Does he quantify this? Hell no. Is it significant? Who knows? In reference to page 215, Miller supplies direct evidence of the effect of bending when he states that an end load of 282 grams placed on one end of the 4 arms produces a shift of 1 fringe, as in we're putting a totally non-symmetrical weight on 1 of 4 points radially around this thing. And what do you know? It distorts. And none of that happens when they're taking readings, so I don't know why he would do it. Anyways, we may reasonably assume half this load, delta is 141 grams, placed simultaneously on two opposite arms would have produced the same of effect. And I don't know that's true either, because the whole thing is floating on Mercury, right? So that there is a radius to consider in dropping this force on the arm, not just its distance from the axis, but its distance from floating on the Mercury. You know what I mean? It's vertical component. There's a triangle of torque being done here in the vertical that he's not addressing. Okay, a simple argument now gives the fringe shift due to an angular rotation of alpha 1 over about B2 in units of one fringe as of the equation 3, where Q depends on the weight of the beam and on its distribution. And the analogous formula holds for rotation of A2 about B1. We obtained, citation 12, I question that. We obtained for Q the value of 48 times 10 to the 3 grams. What is that actually, fans? What value is that actually? I mean, he went to the time of specifying 282 grams in normal notation, 141 grams in normal notation. But this is 48 times 10 to the 3rd grams. No, guys, that's just 48 kilograms. Why did he express it in those terms? Why? Because his analysis is totally less intuitive from that point, just because of that choice that he made in his documentation. Okay, from equation 3, we can find the angle alpha 1 necessary to produce the total fringe shift N1, 2 times 0.044, which is the mean of the observations on Mount Wilson. The result is alpha 1 at 1.3 degrees, which seems too large to permit an interpretation of the observed fringe shifts in terms of a wobbling motion of the slowly rotating cross, one turn every 50 seconds. Now, why does he say one turn in every 50 seconds, guys? Again, this is something that you'll see in an upcoming display of his cherry-picked data, where they take 20 turns and 16 samples per turn, like I was telling you about the cardinal directions. They take 20 turns in a session. Well, they do that in less than 20 minutes. They just move it and check it and move it and check it and move it and check it and move it and check it. And they do that for 45, 50 minutes straight to produce 20 rows of data, 16 columns wide, one for each azimuthal point. But smaller laboratory irregularities, perhaps of the order of a few tenths of a degree, must undoubtedly have been present in Miller's experiments. In order to find out about their possible contributions to the results, the dynamic constants of the apparatus in rotation were determined, and a simple analysis of its motion was made. Yeah, by you, Shankland, hey? Assuming the apparatus strictly symmetrical about the vertical, one obtains for the moments of inertia C and A about the vertical symmetry axis and about the horizontal axis through the center of mass, respectively. And this is what I was talking about, how they have to consider that it's floating on Mercury, although he never mentions it again. The center of mass is 40.5 centimeters above the centroid of the displaced Mercury, and the metacenter is 210.5 centimeters above the center of mass. The restoring moment produced by a small angle theta between the symmetry axis of the apparatus and the vertical theta d, where d is 2.48 times 10 to the 11 dyne centimeters. Now, this is a unit of measurement. I'm sure you guys might remember when we were talking about the Marinov motor and the replication that it did last year. You guys remember that one?
Oh, yeah.
On how many dynes of torque we were producing on 27 amps of current going through it? that a dyne is like millionths of a foot-pound kind of thing. So this 10 to the 11th is nowhere big as they would purport or have you believe. And it is because of his unit of measurement here that that exponent is so drastically high. Okay, the period of roll about a horizontal axis through the center of mass is therefore only 1.2 seconds. And I don't know if he means arc seconds there or measurement seconds. You know what I mean? That's a little vague. Anyways, the motion of the system may be considered as that of a hanging top. The restoring couple is theta d. Depending on the fixity of the centering pin, which was not the same in all experiments. The fixed point may be identified either with the center of mass itself or with the bearing of the pin, which is about 51.5 centimeters below the center of mass. The equatorial moment of inertia is, in this latter case, a 1.22 times 10 grams per centimeter, grams square centimeters, actually. I should get that straight. 1.22 times 10 to the 10th grams centimeters squared. C and D are, of course, unchanged because they're aligned with the axis of motion that they're talking about. Let us consider the motion in the neighborhood of steady rotation about the vertical axis of symmetry. The values of the constants A, C, and D, together with the very small spin radius of 2 pi over 50 per second, are such as to preclude regular precession, whichever fixed point is chosen. The motion is of the rosette type. The instantaneous position of the symmetry axis be given by, and you see it in equation 4 between theta and psi here, with the 2 omega values. Here, theta and psi are the polar coordinates of the axis of the symmetry, and what is an eta? Is an amplitude constant characteristic of the asymmetry of the initial impulse. So this very well just could be because they're saying they're spinning this thing and moving it by hand, and maybe the forces that they're putting on it are causing it to become, offset or tilted or not level anymore. I think that's what he's kind of driving at here. It is now possible to find an approximate expression for the fringe shift due to the angles alpha 1 and alpha 2 subtended simultaneously by the limbs B1 and B2 with the horizontal plane. When the symmetry axis moves according to equation 4, one obtains this one in equation 5 about delta n, or delta, he's changing from n to eta partial way through the equation. That's confusing as hell. Way to go, guy. The circular frequency omega 1 is very close to d over a to the half and corresponds to the roll period mentioned before. Thus, delta n oscillates with twice the roll frequency, the amplitude being modulated with the circular frequency 2 onto r minus omega 2. The value of omega 1 is not very sensitive to a change of fixed point. The roll period increases from 1.2 seconds to 1.4 seconds if the fixed point is assumed at the pin bearing. The period of modulation, however, decreases from 39 seconds to 10 seconds if, instead of the center of mass, the pin bearing is assumed fixed. Obviously, these rapid oscillations cannot account for the true second harmonic period of 25 seconds, which strongly dominates such runs as shown by sheets 79, 75, and 42. And notice that he lists them in reverse order here, exactly as he has them listed back as we saw in table 2, with those 5 rows in them. Beyond that, one may in general expect the contributions of these oscillations to cancel each other in the average throughout a set of 20 runs. In order to estimate the efficiency of the averaging process, assign to the amplitude constant eta the improbably large value of half a degree. Compute a table of 20 rows, as in 20 spins of the wheel, all the measurements, 20 times 16 measurements, according to equation 5, by setting t equals 50k over 16, where k is 1 to the iterations of 320, all the measurements. You know what I mean? 16 times 20 is 320. And determine the column averages, delta n average for the iteration. It turns out the maximum value of the data n stays well below, what is this, a 200th of a fringe. These conclusions would not be strongly affected by a slight asymmetry of the apparatus about its vertical axis, as must undoubtedly have been present, even though he wasn't there to confirm it. He has no doubt. These guys botched it. Effects of temperature. Miller's 1923 lab tests of the effects of thermal variations on the interference fringes have been studied with the view of establishing their relationship to his Mount Wilson observations, where temperature effects due to intense sunlight during the day and to canyon air currents at night were often troublesome. Miller's own suspicions that the thermal effects might be important are shown by the entry in his lab notebook for April 14th, 1921, saying, sun shining full on the side of the house, there was a very large drift which seems to be in the direction of the sun, indicating possibility that the entire effect is due to temperature. Well, maybe it's due to the presence of the sun. But he's not going to look at that because of the way that he's stacked his averaging, like we talked about before. In the lab tests, electric heaters were placed at the level of the mirrors, as in the vertical height of the mirrors, and about 3 feet from the circle traveled by them, as in 3 feet farther radially away. The altered refractive index of the heated air and the thermal effects on the mirror supports change the mirror supports change the optical path lengths of the interferometer. And when these are affected unequally in the two arms, the fringes shift in position. On the assumption that the 4 arms of the interferometer all have the same thermal insulation, a localized temperature anomaly or a temperature gradient across the room will produce a second harmonic term in the fringe positions as the interferometer rotates, similar to that anticipated for an ether drift. Now, is that actually true is the question. He's saying that if there's a horizontal temperature gradient across the room, that's going to affect the orientation of these mirrors because of, you know what I mean, expanding and contracting materials themselves upon which they are sitting. But is that really true when they're spinning this thing faster than 1 RPM? Is that really true? Because you have to consider the density of the materials, the gradient itself, how much different is the temperature in terms of maximum minimum relative to the starting temperatures of all the materials being spun around on the wheel. You know what I mean? And the diameter of the wheel itself. How far are these things actually moving side to side within the actual room? How big is the temperature gradient one side to the other? You know what I mean? I call bullshit. Okay? Anyways, localized heating will also produce a first harmonic in the fringe displacements when one of the 4 interferometer arms, for example, that containing the observing telescope, has different thermal insulation properties from the others. The effects of heat on the 3rd, 4th, 5th, and higher harmonics of the fringe displacements should be small for any temperature conditions likely to be encountered. I agree with that. The lab tests of 23 were conducted with various amounts of insulation protecting the light paths and mirror supports. In some trials, the air was directly exposed to the heaters. In many cases, the glass and wood casing that served at Mount Wilson as insulation for the light path was employed. And in certain experiments, additional corrugated paper was placed over the vertical glass walls of the casing, the mirror mountings, and in some cases over the steel base of the interferometer as well. In the experiments where the air in the optical paths was directly exposed to heat, large secondary harmonics, alpha to 1/3 of a fringe for 1 heater and about twice this for the 2 heaters, were always observed in the fringe displacements and with the expected phase. Now that I believe. You see, now you're forcing the gradient, but you're moving the air. You're hitting it with a heated flux path of air. Of course it's going to change it. Yeah, okay. Anyway, shifting the heaters to a different azimuth produced a corresponding change in the phase of the second harmonic, which I also believe is to be true. Obviously, when the optical paths and the mirror supports were thermally insulated, the second harmonics were greatly reduced. Go figure. For example, with the glass coverings as used at Mount Wilson in place, the amplitudes were reduced to about 0.07 of a fringe, as in 3/4 of a tenth of a fringe. Among the lab trials made by Miller at Case in 23 are 4 sets of observations which reveal... Are you okay there, Alan? Are you trying to find where I'm at? I think you got me. Yeah, you know where I'm at. 4 sets of observations which reveal rather clearly the character of the temperature effects. In these sets, the optical paths of the interferometer were enclosed with glass thermal insulation as used at Mount Wilson. And in addition, corrugated paper was placed over all arms of the interferometer. In 2 of these trials, no artificial heating was used, but in each of the 2 sets immediately following these controls, the heater in the position mentioned above was in operation. The results of these experiments are given in Table 4. It is evident that the heater produced disturbances which increased the amplitudes of all 5 harmonic components. However, the effect on the second harmonic, K2, is much the largest as is to be expected on the physical grounds. And that's also true mathematically speaking, you could expect that. Furthermore, the phases of the second harmonic in sets 18 and 29 have values consistent with the positions of the heater. That's what, 2 sets out of 30 or something? Like what? I don't know where he thinks he's going with that statement. But anyways, the first harmonic, alpha sub 1, is somewhat increased by heat. And for this also, there is some physical justification. Yes, indeed. You know, it's a heater and you're blowing air at your interferometer. This increases the amplitudes of 8, 2, 3, 5, or 3, 4, and 5 are smaller. Okay, it must be emphasized that the foregoing analysis of these tests reveals small but certain temperature effects, in contrast to Miller's statement that he had shown the absence of periodic effects caused by artificial heating when the light path was thermally insulated as previously described. Similar conclusions regarding the danger of spurious second harmonics due to thermal conditions were reached by Jost in his elaborate preparations for a replication of the Michelson-Morley experiment at Jena. In fact, Jost concluded from his laboratory trials that the temperature disturbances would be so serious that photographic recording of the fringe positions would be impossible except in a well-insulated basement lab. Thus, Miller's experiments in 23 do not rule out the possibility of attributing the remaining systematic effects of Mount Wilson data, which are most prominent in the second harmonic A2 and to a lesser degree of the first harmonic A1, to temperature causes. Did you guys catch that? He's saying
what was it?
it's nuh-uh, and you can't prove that it wasn't a factor.
Oh yeah, the old nuh-uh. Yeah, classic, dude.
In what follows, we shall interpret the systematic effects on this basis, but must admit that a direct and general quantitative correlation between amplitude and phase of the observed second harmonic on the one hand and the thermal conditions in the observation hut on the other hand could not be established. The reason for this failure lies in the inherent inadequacy for our purpose of the temperature data available. And again, we're going to look at the temperature data that they put on the 1923 page that he cherry-picked and only showed us one run of 20 in a sec. Okay, let us first discuss the physical consequences of weak radiation field maintained across the hut by the temperature differences of the walls. Since periodic temperature variations of only 1,000th of a degree in the air of the optical ions would produce a friendship as large as the average effects by Wilson. A very conservative estimate was made of the wall temperature differences necessary to produce temperature oscillations of that magnitude. For this purpose, it was assumed that 1, the ambient air temperature in the hut was essentially constant, and 2, radiation was absorbed only by the vertical glass plates in the casing.